Okay, example one, escape, please see the text. Okay. Okay, example one, there are two functions given by graphs. They are graphs. So we can express a function in terms of its graph or some formula, or even by some explanation. X approaches -2. -2 is here. Okay, the limit of the function f at -2. 0, this is 1, this is 2, -2. -2, okay. Approaches 1. So this limit exists at -2. G, the yellow one. here. Oh, minus 1. It exists too. So according to the limit theorem, this is limit preserves addition and constant multiple. This is 1 and this is minus 1. Minus 4. When x approaches 1, 1 is here. F approaches 2. When x approaches 1, the left hand side approaches to minus 2. The right hand side approaches minus 1, does not exist. Therefore, this limit shouldn't exist. Two. Minus 2. Two. Minus 1. These two numbers are not the same, so the limit implies that find them at 2, 1, and 2, 8. F of x g of x, 0. Okay, does not exist. And this one is non-zero. In fact, here 1, almost 1.5. Who knows? Okay, does not exist. So this example, from this example, we learn how to use the limit laws. How to use the limit laws. Limit, if all limits exist, preserves addition operations. And here we use the limit and the relationship between limit and two-sided and one-sided limit. Let's see, we learned the quotient law of limit. More precisely, if this one exists, will be L times 0, a contradiction, because this is non-zero, but this is 0, a contradiction. This contradiction shows this limit does not exist. If, suppose on the contrary, this limit exists, equals some number L. Okay, suppose. Maybe very large, maybe very small, or 0 anyway. Suppose on the contrary, the fact is does not exist, but suppose on the contrary it exists, equals L. We would, this one equals f of x over gx times g of x. This limit L, suppose. And we already, from the graph of the function g at 2g equals 0, this limit is 0. Exists L, exists 0, so use the product law, we would have the limit of the function f at 2 is 0. This contradicts the limit of f at 2 is non-zero. Okay. 可以吗？就是分子的 denominator is 0, but the numerator, the limit, denominator is 0. The limit of the numerator is non-zero. Okay. Non-zero is 0. So this limit have to, shouldn't exist, does not exist. Why? Why? Explanation here. Suppose, on the contrary, or to the contrary, it exists means this exists means that this one equals some real number, L, say. Call it L. Then this limit exists, and this limit also exists here. By inspection, g, when x approaches 2, see? 0. So we already have this one, and we already have this one. So by limited law, the limit of the product equals the limit of this one times the limit of this one. The limit of this one already supposed to be L. And we already have the limit of g at x equals to 0. So we would have this one. And this equals 0 and not 0 conflict, contradiction. So does not even exist. Okay, so sometimes the answer may be easy to get, but you had better to give an explanation. What? No. Okay. Oh, yes, yes. Go ahead. Yes, sometimes take a picture. It's faster than write down. The function g is given by when x is not 1, g of x equals x plus 1. If x equals 1, then g of 1 equals pi. But when we deal with limits, we don't care. We never care this one, this position. We only consider x, which is not 1. If x is not 1, then g of x equals x plus 1. And this is a polynomial function. Constant function, identity function, so we may obtain this answer by direct substitution by letting x equals 1. 1 plus 1 is 2. Of course, the geometric interpretation is this. So the graph of the function g is a straight line. This straight line has a gap here. Jump up. When we are talking about the limit when x approaches 1, we don't consider 1. So we just consider x which is not 1. In fact, not 1 is exactly this function. Same. This one is good. This one is good. So these two functions have same limit when x approaches 1. This again, when we talk about limit, we don't care the value of the function at this one. Maybe defined, maybe not defined. Maybe defined and maybe not defined. But outside 1, I mean, for x, which is 1, these three functions have same values. Have same values. So these three functions have same limit when x approaches 1. They are all 2. They are all 2. So the domain of this function don't have 1. Because if x equals 1, this is 0 and this is 0. 0 divided 0 over 0 is undefined. Okay. Surprise. Okay. You cannot cancel this. Can't. The x, when x appears in different situation, they have different name, different property. Okay, let me consider more. X minus 1, x plus 1, x minus 1. If we consider this as a fraction, very good. This fraction equals can be canceled. If a function okay, here x has a name, indeterminate. Indeterminate, I'm not sure. Maybe. Just like a generalized number. But here, x is independent. variable. So this one is not equal to x plus 1. So this is another function, but this can be written as x plus 1, but x with this extra condition, independent variable, independent. And the third, the solution of this equation only x equals -1. In this case, we call x an unknown. Okay. So when we deal with function, treat x as an independent variable, we cannot cancel these two factors. Otherwise, we'll become to another function. Okay? Got it? Got it. 所以我们只是会算东西是有问题的。当我们讲到分式，这个叫做有理函数 ，a rational function. This is a fraction. This is a rational function because quite similar to a ratio of two integers. Generalize integer to a polynomial. So this is a rational function. Or anyway, when x as independent variable, you should have to notice when you cancel this, then become to other function unless you give extra condition. X is not equal to 1. Okay. 所以在函数的时候叫做独立变数，叫自变数；在分式的时候叫做不定元。那么在方程式里面的 x 叫做未知数，都是数，但是你要特别注意。When we talk about this, independent means a generalized number. For example, from 1 to natural number with 0, -1, -2, we have integer, then 1/2, and for example, then irrational. So suppose we have real numbers, then we add some new one. Then we add not only a polynomial but also the quotient of two polynomials. For example, so here x is not 0. 0 is this guy. X is this guy. X is x. A new guest, new customer, new one, a generalized number. Okay. So this is real numbers. And this is a polynomial in x. And if the division is allowed, then we have rational. Oh, fraction. Okay, fraction. So in here, this is a -0. Here. X -1 is not 0. 0 is here. X -1 is here. they are different polynomial. Non-zero, so we can cancel. These two factors are the same, and non-zero we can cancel. Because where is the zero? The zero is here. Okay, but here, all different. X may be 1, maybe 0, maybe minus 1, maybe 2. Because when we talk about function, x is independent variable. Okay, and finally, equations. In equations, an x is called an unknown. Okay. Thanks. See you next week. 其实问的很。